So, first of all, a good morning for you. It's good evening here in India. Warm welcome.
Hey, good evening, folks.
So, if you want to take questions in the end or in the meanwhile in between, you can just ask people to raise hands. If they will be here on communal stage, they will be asking by joining the live on stage. Otherwise, if the questions are from YouTube, I will be just sharing them.
Cool. Okay, so we start.
Yes, perfect.
Okay, welcome to the talk about how we can use AI and augment in our product and system management. Um, the product management is part of our product life cycle in our software life cycle, and then system management is core of our engineering, especially when we are maintaining our production system. And in this talk, we are going to talk about how we could use AI data insight to improve the product management and also overall our production system management. Brief intro about me. I'm Manivandan Dhanashekharan. In short, you can call me Money. I have 20 plus years of experience, and most of my experience around supply chain, e-commerce, big data, and then I worked on building the low latency, high throughput microservices, orchestrating using event source and service bus. I also worked on big data in petabyte scale and also very actively now working on AI and ML engineering. I used to work for Dell.com before I joined to Amazon. And my initial career is creating business intelligent dashboards using the data what we acquire from our Dell.com customer interactions. Um, I used to be Microsoft MVP 2007 and to 2010. But recently, I'm not that active in Microsoft communities nowadays. The today talk, as I said earlier, in our modern software system, it's become complex and distributed. In the current world, we can't build a system standalone systems. Our systems are always going to be interconnected. These interconnected systems could be have a dependency within our org, maybe because we created different verticals for roles and responsibility separations. Or these connected system could be depend on outside of our own organizations where we need to process payments and other services which is vended by other third party organizations. So we can't build a standalone systems in this world. And when we do that, we need to see how our system is performing and we need to manage, and then we need to make sure our system availability is always higher. We are not impacting our business and our customers. So the problem is how we are going to predict there is going to be issue cost, how we are going to prevent those failures, and not only detecting that what is the problem with our system, and also how we are interacting, how we are reacting to those failures. As we grow, as the volume increases, as the number of user bases increases, these challenges also increases proportionally. So today agenda, we are going to talk about how we can move from reactive to proactive intelligence. Mostly we are going to use Microsoft Fabric and how we could use Microsoft Fabric to support our use cases. We also take couple of case studies and use cases and we will go into depth. At the end, I will share that how the implementation framework and some of the learnings from our my experience. And then finally, we will leave to the Q&A session. Before we jump into the actual case studies, the problem which we are going to discuss. A quick detour about Microsoft Fabric. Microsoft Fabric, I worked in multiple cloud tools with GCP, with AWS, and with Azure. I don't think so. Other cloud platform offers equivalent of Microsoft Fabric. They do have these base core components, bits and pieces, but not like how Microsoft Fabric, which brings in all the data under single umbrella, and we can have a seamless experience by connecting all these core components. As like any business intelligence tools, data is our key. So the one lake is provides an option to bring in all the data. We could think about it's like a staging data. Then direct lake offers the direct connection with the data from our either from our Power BI, or either we could use any other tools such as um, the Copilot, that is the natural language processing. And then finally, we could use the managed Custos query language to understand the patterns. And not only just visualizing and understanding the pattern from the data, we could also trigger events. We could also take an actions by using data activator. And if you think about it, we step back, this is what usually we do in any BI. The BI is trying to collect the data and then understand the pattern, represent the pattern, and then using that pattern, we make the decision. And this will happen in a large scale with large data. In some cases, we are going to automate everything end to end. As I said earlier, the data explosion challenge, since our software systems are increasingly getting overwhelmed data, it could be the customer interactions. The customer may have multiple touch points, and we need to understand how our customers interacting with our systems. And that's where the customer interaction data are going to be there. It's mostly used for behavioral studies, and then how the customer using our features or dropping from our workflows, or the click stream path. And similarly, there is system telemetry. As I said earlier, we can't build standalone systems. Our systems always interconnected and distributed, and each of these system going to give the telemetry. And when we have this telemetry data, one of the biggest challenge for us is how we are going to correlate how these chain of event happened when the systems are distributed. And then we do have the application and infrastructure logs, and most of the application infrastructure logs are logged at the server level or at the application level. Again, we need to correlate those instances with the system telemetry. And then the system telemetry doesn't produce by itself. It has some triggering point because of some kind of customer or service interaction. So we have to correlate all these actually. And when we do these data, and then finally we end up with having billions and billions of data in our hand. And in most of these data, what we collect is sitting in our cold store. And then having manual analysis on these data is biggest challenge for us. And that's where the Microsoft Fabric One Lake solved this problem, where we could very efficiently collect the data using event streams. And then we can create the data flows to create structured pipeline to scrub the data to us. If you step back, um, in when we don't have the proactive operations, most likely we will end up with a reactive approach. The reactive approach, when especially when we want to monitor from the product point of view after we deliver the feature, we want to see that how customer interacting with these features, and that requires the manual monitoring. And we need to go and collect the data, and not just collecting one of the data, and we need to correlate multiple other data, and then we need to understand the behavioral studies. And these are very manual process from the product angle. Similarly, when we have a system and we want to keep the system health, To keep the system health, we will have the telemetries and monitoring, dashboard, alarms, and everything. But at the same time, these are manual. Most of our alarms indicates that there is already problem happened. We are already impacting our customers, and then it notifying the on-call engineer saying there is something bad happen and then take an action. It's already too late for us. In historically, whenever these thing happens, what we try to do is we try to set the early detection alarms. The early detection is pretty much like, okay, instead of reaching a threshold, we will reduce the threshold further. And if you reduce the threshold further, then what would happen is your system may create more alarms. And as an on-call engineers, they go and see that, and the moment they log in and see what's happening, they may be the alarm already below the threshold, and then everything system functions normal. It creates a lot of noise, and it is very expensive, because on-call engineers being triggered with alarms, but when they go back, there is no real issues. And when the real issues comes, and then that is going to be a really a big problem for us, because there is a lot of noise actually. And sometimes when we have a lot of noise in your system, you may miss that real issue when it happens. So how we're going to move from the reactive approach to proactive intelligence? One of the advantage in the proactive intelligence is there is no static thresholds. The system understand the characteristics of our service pattern, customer behavior, and then based on that, we can smartly define what is we can make the early detection and what is our tolerance level, and we can do this in a real time, instead of waiting for something bad happen already. And not only identifying the pattern anomalies, but also we can do automated interventions. Automated interventions or data activators, basically is kind of a trigger where we can make a certain action. These actions could be as simple as executing few commands. For example, if there is something bad happens, and we can see that, hey, is it bad happened because of recent deployment? If it is recent deployment, we could roll back. Or we could, as simple as we could notify the team saying that, hey, there's something bad going to happen, and then we can notify our on calls to take a look on it. And here there is no static threshold, because most of the static thresholds are just the horizontal line, but instead these lines are the ranges are aligned with our traffic pattern basically. So it's basically whenever there is anomaly detected, it try to intervene. How we are going to leverage the large scale AI models in our fabric? As I said earlier, whatever we do, it is going to impact our business. The business impact we could approach in two angles, as I said earlier. Either it could be we are giving a positive impact to our customers, like building new features, or we understand that which feature our customer pay more attention and then see how we can improvise. Or we could see that which feature the customer drops from using it and then how to improve it. That could be the business impact. Or how we can prevent it, the good system going into the bad state. That's the business impact. To do this, we need the model training, and then we need the prediction pipeline. And model training, when Microsoft Fabric, it comes very naturally. All we have to do is have a notebook and then Azure ML integration. Using the direct data lake, we can connect our data to train models. And also, Microsoft Fabric offers there are multiple models we could use, and then we can put our data and then get the future scores, and then based on the score, not only just identifying the what is going on, we can also predict that how we can take a certain action when there is something goes wrong. And that's where Microsoft Fabric allows us to do from the notebook and also from the direct lake integration. Let's talk about the use cases, how the product management could use this Microsoft Fabric feature. So when we build any software system, these software system going to have multiple feature, and each feature going to have different level of customer interaction. We never build any of the feature which we think that customer never going to use it. Whatever feature we are building for our customer. But at the same time, from the customer point of view, the customer behavior changes. It could be because of the customer what they wanted is only served by a certain feature, or certain features are not really very customer friendly. And these kind of analysis of which feature and how the features characteristics, and we can collect most of the clickstream data and other information from the customer behavior. But using that data, we can use Microsoft Fabric to understand how these features are helping our customers or not helping our customers. And that's a great insight for any product management. And that's where the product management really want to see which is the key feature for our software, where it is lagging the engagement and why the lagging engagement is. Again, in any software system, when we have built the future, demand forecasting is very important. Again, the demand forecasting in the sense when we know that there are customer highly interacted, and then we classify them as our critical feature in our system, and then we try to how we how we maintain those critical system is different than the features which have less engagement. And the demand forecasting need not to be just on the like I said, inventory, but it can be the infrastructure forecasting. We can predict that, okay, the peak period is coming, like the Diwali seasons, then this is where our load going to increase. And we can go back to the previous year characteristics. And then we can see that, okay, and we can say year over year, what is our growth? And then use our previous year analysis. And then we can predict that how we need to be prepared for our infrastructure need. And that's where our demand forecasting going to help us. It help us to be prepared, not waiting for something bad happen or our service overwhelmed because of the high traffic. Instead of waiting for that happen, we be prepared and then make those infrastructure ready to support our high load. And that's where the demand forecasting going to help by using our historical data. Again, for that, we need the Power BI and Microsoft Fabric going to really helpful for us to understand that. Again, personalization. I think the personalization is the key, and it's not only any customer interaction. We, if you are not giving personalization, the customer doesn't feel like they engage with our platform. We would witness from any of our customer interaction with platforms such like Netflix, for example. If everybody gave the same content is shown, if there is no personalization, our customer doesn't feel like they engage with those contents. And personalization is a very key for a lot of customer engagement. For that, we need to understand the behavior, and then based on the customer behavior, we need to tune how we are going to offer or how we are going to present the feature to our customers. Again, the experience of the personalization is the key for our product management. And how we power that personalization for our customers is by looking into their historical data, understand the pattern, and then recommend the right feature or right experience for them. And then finally, as a product management, all we need to do is how we are going to prioritize the roadmap. And that's a very critical thing because we don't want to spend our engineers where the customer is not going to engage with that feature. That is waste of resources and waste of money and waste of time. And to prioritize the right roadmap, again, we need to look back into some of our data and listen to all these. We need to understand that our customer behavior, our future performance, our demand forecasting, we should collect all these data and we should prioritize our roadmap here. And that's where the ML prediction and then the AI powered Microsoft Fabric going to be helpful for us. In product strategy, like any other BI, first we will start from the data ingestion. We use all the telemetry data. We will bring this data into one lake. In this particular case, these data could be, some of them are customer, these are different entities altogether. Some of these data entities could be just the customer interaction data. Some of them could be server characteristics or telemetry data. And then some of them could be how we are interacting with our other dependent services. So we bring in all the data and then we use the our fabric notebooks. We will try with our right models and then score those features and understand. We could use the KQL to understand the patterns. And then using the patterns, we can create different dimensions and we can set some anomaly detections. Basically, that's where the model training come into play. And finally, once we have this data, how we are going to use Power BI to visualize this information to our customer. When it comes to visualization, there are two levels of visualization where we can build the models in Power BI. And after Copilot integration, we could also make the natural language interactions with our data. Again, the natural language interaction still goes back is using the data, whatever the model train data being put back into our one lake, or they can directly access the data from the one lake to answer the queries to our customers. And finally, not only presenting the data, also we could make an action. The action, some of them could be automated, or some of them could be used to influence our engineering team on where we supposed to work. And having these kind of data clarity will help us to reduce a lot of churn, and we can focus our energy on the right problem set in our software architecture or software development lifecycle or the core features what we are building. And identifying the right priority is one of the hard problem. And without having these data insights, we don't know what whether we are working on the right problem or not. From the technical implementation point of view, the data ingestion could happen from the event stream, and then it can be processed through the lake house. We can have the notebook for the model training, and then we can scores in delta, and then we can process the delta into delta tables. And finally, we can connect this data into Power BI. So it's a typical BI how we use. I think the major difference are the value proposition here using Microsoft Fabric is building everything under single umbrella and also having access to the extensive models to understand the patterns of the data. Um, so far, we discussed about how, as a product management, we could employ Microsoft Fabric to understand what is the customer behavioral characteristics, and then what how we are prioritizing our work. But in this particular case, we are going to discuss more about how we are moving or how we are evolving our operations. As I said earlier, most of our dashboard, which talks about our system health, it is the traditional monitoring systems are having a very static threshold. And if you look into our graphs and everything, we say that, hey, this is the just a horizontal line. And then we will try to see that whether that horizontal line, whether our telemetry data is within the range or outside of the range. Whenever there is outside of the range, we cut alarms or we cut a ticket to our on calls. We expect them come and intervene manually to fix the problems, right? I think the biggest advantage in the Microsoft Fabric or any ML ops or AI ops is it's not a static threshold we are setting. We are setting a anomaly detection. That means we understand the patterns. And then once that pattern is outside of the range which we expect, not only it alerts, but also it takes an action. And whenever that action is safer, that's very important. We can't just do any command execution. I don't think so. We are not there yet. It depends on we need to try out. There are certain safe commands which we could execute. As I said earlier, when there is something happens, if there is a new deployment happen, and everything correlates together, one best attempt we could do is we could roll back the into the good deployment, which we know where it worked very well. That could be the data activator, or we could just say that hey, cut the ticket. That could be the another data activator. The activator need not to be always raising alarms or writing the tickets. It can execute certain commands. It's basically just a trigger, basically. But we need to make sure the action which we are taking it's safe to execute by our automated systems. And if you think about it, we started with the product, how we are understanding customer behavior, how we are prioritizing the right future for our customers. And we also talked about how we could use the ML ops or AI ops using Microsoft Fabric, how we can take certain actions. It's not only stops there, right? If you think about it, any time when there is a problem happens, we need to go back and understand what really went wrong. In my experience, root cause analysis is very difficult. Even certain cases where we make an impact to our customers and we firefight to understand what's really going on. And not all the system problems what we receive is the just a black and white. Sometimes these issues happens intermittently. That is really hard to troubleshoot and really hard to fix the problem, especially when you have a high throughput services and you have to serve the traffic to your customers, and also you need to understand what is the issue, which pattern causing that problem, is it impacting for the all customer. When you are running a software, if you're impacting all the customers, as the DevOps engineer, I know that exactly what is happening. I would be happy. I know that exactly where to pinpoint the problem and I can fix the problem. But if it is impacting a certain type of customers, narrow downing what's really happening is really hard. We need to go and understand which thing is correlates, and then we need to go and find the problem. It's like searching a needle in a haystack if you are running a very large scale system in this particular case. And usually, as an engineer, when I deal with this kind of a problem, our dashboard says there's something wrong, but when I go look into that particular system, looks everything good. Then that's where we need to go one level up, and we need to understand the patterns. What really triggering this problem? In very common case from the system engineering, we see that our latency increases. As the latency increases, the throughput will drop. As a throughput drop, it create a back pressure to our upstreams. As a creating a back pressure to the upstream, now we will see the lot of the messages in a queue spill over to the dead letters. A simple latency increase, it creates the cascading effect, not only to the downstream, even to the upstream, the way how we design our system. But just looking into our system is sufficient enough. If I am my upstream system looking into why the dead letter is happening, spillover happening, is not sufficient enough. They need to get that full insight of what is happening. And manually going through putting all these graph and then skimming through by the human eyes is really difficult. And that's where Microsoft Fabric and AI ops come into a play, where they can easily understand the pattern detection, and they can say that what is happening on anomaly maybe not directly indicates that that's a problematic system, but still it helps us to narrow down what's really happening. I think the root cause analysis is going to be really um, simplified when we have all these data put together, and when we run a KQL queries, we can really understand some of the good patterns, what's really happening there. And this is the one of the biggest advantage I see from the root cause analysis. The moment we know that what is causing the problem, when you're able to correlate, then your mean time recovery is going to be very simple. But most of the time, our mean time recovery impacted because we don't know what's really happening. We always assume that, okay, as the data size increase, how our AI ops going to work. Um, I manage a system which process billions of data every day, and use the AI ops and then Power BI to make the decisions. The volume is not a big blocker for us. I will talk about later what is our key things which we need to focus. But all we need is how we are building this infrastructure scalable for our large volumes. When I started my career, um, we don't had a cloud infrastructure when I started my career. We don't know how to process the large data. But using Microsoft Fabric or Azure platform or any other cloud platform, processing large volume is not a blocker or a bottleneck for us. But at the same time, as a volume increases, we need to watch out the return of investment, how much money we are burning, and then we need to do that ROI study. But the volume is not going to be blocker for us. And practically, from my experience, we get a lot of insight to understand what's really happening, because the interactions what I support is a very high throughput services where we support billions of requests every day, and we still create the interfaces and then dashboard to understand what's really happening, and none of the human can understand what's happening on those billions of requests. And we need some automated system to define the patterns. Even sometimes, even for us it's a big learning curve, and we every day we encounter some interesting findings, what's happening and how our customer behavior changes, and how our system's supposed to react to those changes. For that, the main thing is you need to have an event stream and event house continuously ingest the data in a streaming fashion, and then aggregate and summarize in the data which your dashboards and other anomaly detections and your models can understand. That's a key thing to setting up, and that's one of the biggest value proposition when we use the Microsoft the Fabric. So the framework is simple. We already have some kind of sense how we are going to do it. In any BI platform, the first thing what we have to do is ingest the data. Typically, we call it as ETL, and then we need to train and score. The biggest advantage of using Microsoft Fabric is you can have a notebook, and then you can directly connect with your lake, and you can use whatever the models available to train and score your data. And using Power BI, you can visualize, not only visualize, you can also create your data activator by using your monitoring and triggers. The triggers could be as simple as some comments, or it can just trigger the tickets to your using your team systems or any other system integrations, whatever you have. And finally, the feedback loop, that's very critical thing. Any AI ops is not autonomous system. It's autonomous system in the way of automated way, but still it requires a feedback loop. We still need a human intervene. The human intervene could be in two folds. One is we need to understand that, okay, do we do this correctly? We need to measure and then improvise that. And second thing is when AI ops makes in most of these AI decisions, these are probabilistic decisions by using the pattern recognition from the past. But there could be a real anomaly. There could be some false positives, or there could be some true negatives. And when that happens, we need to understand that how we are going to use human to override those decisions. So we can't just rely on the AI ops. The feedback loop is critical. That means you can't just build a system and then you expect that the system will work forever. We need to find a way how to measure and how to improvise our whole fabric. And that's the interesting thing. Right? So the AI going to help us to analyze the large volume of the data. It is faster than human. It can easily recognize pattern because you are providing the data and you are asking the model to go and figure out what is the anomalies and pattern is happening. And it can scale for any scale or any large scale of the data. When it comes to humans, the humans can understand the business context and they can also realize that why this is happening. For example, the order could be dropped, or if your traffic can be slowed down if there is a cricket match in India, right? So that doesn't mean that from the AI point of view, it may say that this is an anomaly, saying that hey, there is no customer interaction. It may assume that there is some system failure on your upstream or downstream, but that's not the case. But the human can understand the context of what is happening, and also they can understand how to interact with other stakeholders, and then they can do the stakeholder management. So finally, we need to combine these together, and then we need to make better the ecosystem and then AI intervention tool. So what I'm trying to say here is we can't just build the AI systems as an autonomous and we leave completely the human out of the loop. Um, as I noted earlier, when I started my career, there is no cloud infrastructure, and all our services which we deploy, either it is hosted, if it is internet, we need the DMZ zones, and then we will connect that with our data center, or all our applications runs in our own data center which we manage. And the data center which we manage is not in hosted in a single place, and we try to create the something similar of availability zone, disaster recovery zones, and we create redundancy and everything we done ourselves. And then when the cloud came, we had the trust issue. But now we understand that we all trust our cloud. I don't think so. There are very few systems we deploy in-house, and most of our system now comes cloud first. And the cloud first also take away a lot of maintenance, because some of these, most of the services which we use in a cloud is the self-managed. We don't need to worry about underlying hardware and then underlying operating system and underlying patching issues. All we worry about is what is the functionality I need and how to use that functionality directly as the SaaS based services. And that kind of paradigm shift is going to happen in AI. A lot of organizations are skeptical how much we can trust AI. I think the characteristics or the same concern we had maybe 10, 15 years back when cloud infrastructure came to our software architecture. I think the same thing going to happen, but we need to build the trust and we need to influence our organization how we can build the trust. And some of the things which will help us to build the trust, how the cloud infrastructure they made sure that they can trust the data. They can even now the government also started using cloud. And very interestingly, if you think about it, Netflix and Amazon, though they are revolved from the content deliveries point of view for like Netflix versus Amazon Prime, but Netflix uses Amazon AWS cloud infrastructure to host that. That's the trust they build it, right? Similarly, we need to see that how we can build the trust on the AI augmented system. The first thing is we need to be very critical thing is explainability. We need to understand why the system made that particular decision. That's very critical. And explainability and traceability is very, very important. I worked on few systems, some legacy systems, and the traceability is the key. And these are like 10 years, 15 years old code, and no one engineer understand all the rules, what is happening. These are complex systems. But one thing our early the software engineers they did good job on that is having a very good traceability. And though we don't understand some of the rules how it executes, but if I know what is the input and I can take the trace and I can understand what happened to that input on that system. So that is called explainability. We need to see that how we can make our AI can explain what's really happening. And if somebody questions, if you're able to explain it, then that is one of the way to gain a trust. And then the explainability and the transparency goes hands in hand, and both are pretty much explain about the same thing. And you need to have the governance and compliance. And when we're handling the data, we need to make sure our data is aligns with our regularity compliance, and then you need to understand the data classification and sensitivity of the data, and also honor the other rules like the compliance rules, whatever your org or your region offers. And at the same time, you need to make sure that how when you build these governance and compliance going to impact your AI learning experience too. Bias monitoring is very critical. That's where the human intervention going to be helpful. We need to continuously measure if there is any bias from our models. And then the bias is we can easily see that if your input data is out of distribution and if they don't know how they are making decisions, sometimes bias is what that means is when out of distribution happens. Out of distribution is unknown data. When there is unknown data happens, instead of making the right decision, they may take a certain bias for the system, and we also call in traditional software as a default behavior, and that's what pretty much like the bias. And we need to see that is it data is really the decision what it made is correct or not. I think those things we can do some take the audit some of the data, understand what is your AI augmented systems, precision recall, and this will help us to understand that where is your bias monitoring. Once you have these kind of framework set up, and you can easily gain the adoption from your organization about the AI augmented system. So far we understand the framework and how we are going to do it. The core tool set again, we already touched based on what are the tool set we could use across the different case studies we did. Microsoft Fabric is the brings in everything in under one umbrella. Power BI gives you the visualization and also natural language interaction. Azure ML Notebook give access to the models what you wanted, and then Data Activator completes all this work. Wherever you can automate it. Some of these triggers from the learning from my learning from my past experience. The key success factors is the data quality. The data quality is very important. The data what you store in your lake, if it is not high quality, then all your decision what it's going to make also going to be very poor. And you need to make sure that you are capturing and feeding in the right high quality data. And AI is not magic, and it won't work by itself. If your input is a crap, then it will be crap in crap output. So we need to make sure that we are capturing the high quality data. And then if you really want to make a decision faster, you can't work in silo. You also need to have a partnership with your product team to understand, hey, how you are going to use AI augmented decision for your product decisions, how it is going to impact your DevOps, and how also it is going to impact your other business to make the better decisions. So you need to have the cross-functional collaboration, gain the confidence, and then they have to trust our data what we present to each one of these stakeholders. And then it's a big paradigm shift. And as I said earlier, we can't just expect that AI will solve all the problem. We need to be very precise on what we are using and how we are using and how we are, and then what are the limitations and what are the trade-off we are making. Our engineers need to be trained. Our product managers need to be trained on how to use fabric tools and other AI concepts and ML concepts. When it comes to AI and ML, it's not just that you throw everything and then the model will figure it out. You still need to ask the right question. You need to still use the right model for your output, what you decide output you want to achieve. It's not like throw everything and then see what it catches. That won't work. If you do that, then you are burning money and you are not going to get the best output or outcome from it. Finally, when we talk about burning the money, we need to understand what is the return of investment. We need to have very clear metrics whether it is really helping or not. And one other thing in DevOps we do is we measure what is the mean the retrieval. So we need to monitor some of these metrics and see that whether it's really helping or not. And we need to do continuously audit what is the ROI from our implementation. And when we use these four characteristics, and then we can achieve the better outcome from any AI ops, including Microsoft Fabric. Where we are heading, I think the autonomous decision making is the one of the key, and that is where a lot of AI agentic workflow comes into play. When you really want to do agentic AI, autonomous decision making is a key, and you need to give access to all the data possible, including some of the tools, whichever is safe to do. And then to trigger that, we need to understand what is the situation. That's where the predictive by default come into play. The descriptive is we can we can produce a lot of descriptive metrics, and every data what we gather is a descriptive data. Descriptive data just tells that what is happening now. It doesn't tell us whether whatever happening is happening in the right way or not. And that's where we need the predictive. We need to move from just convert the descriptive to the predictive. And when we do that, then we can have agentic AIs to make the decision based on the those patterns and the predictive analysis what we did. And this is what we call as embedded intelligence. And this is where we are heading. Our industry is heading towards the agentic workflows. And not only one agent and then one agent talking with other agents. It's like how one microservice talks with other microservice. And this is where the future of our AI integration is heading. And each agent is specialized in single task, and then they also know that how to use different tools. You don't need to tell anything, you don't need to code anything. All you have to do is you provide the integration point in your workflow, and then they will figure it out how to use the right tool to gather information, or how to execute the right tool for autonomous decision making. This is where we are heading in future. Okay, so how we can adapt this? From my experience, don't boil the ocean. Start very small. Take a very small data set which you know exactly what you want to do it. Start from there. And that gives you the enough opportunity on to learn, tune, and then once you know that that small experiment works fine, then you can scale very fast. As I said earlier, scaling fast is not a big deal as long as you have event stream, event house, and data activator. That's where the Microsoft Fabric offers. So scaling is not a big deal. But making a high precision decision is very important. And if you take a large data set and you try to measure what is the precision is really hard. That's why we always say that start very small, understand the pain points, understand the gaps, and then go and fix those gaps and find a way how you can continuously measure and monitor what your models and then the AI ops workflow is doing, and then fine tune it. And that's very important. We can't just leave once I have the fabric, I can't lift the hand saying that I'm done. We need to find a way how we are going to measure it. And then document the lesson learnings. And that's very critical. It's like any other software practice. Whenever we encounter, we go back and then see what went wrong. And not only we will find a solution to the problem what we encountered, we also come up with opinion about how this can be avoided in future, not only for you, but for the entire organization. So that's where the best practices coming in. And then, as I said earlier, don't just think that AI is going to be your magic bullet to solve all the problem. We still need humans, especially when there is a critical decision need to be made. Still keep the humans. If you step back, if you go to the customer service experience, in customer service experience layers, we know that what is a safe operation, what is unsafe operations. The moment when there are some certain unsafe operations, it goes escalate to the senior manager levels. And then as the impact and then severity increases, it goes to the higher level. And think about from that angle, what are the things, safe thing I can automate it? And if I want to do something, that doesn't mean that we can't move some of these critical actions into automation. Yes, we can do it, but we need to prove that first of all it's worked well for the small scale and then the safe operations. And when we have enough confidence, then we can move to the next one. In whatever the way we take, building the guardrails also very important. We need to make sure that model doesn't takes an abrupt action. We need to build some guardrails and then monitor those guardrails and then keep the human in the loop continuously. You don't need to keep all the traffic. We don't need to take all the billions of data and validate, but we need to find a way how we can measure our success by sampling or what other mean. Okay, that's all I had. Um, I hope the insights are helpful to you. Um, and I would highly recommend get hands-on with Microsoft Fabric through hands-on labs from the Microsoft Learning Series. And also, there are plenty of talks around Microsoft Fabric in Power BI YouTube channel. I would recommend to go through all those. And if you have any specific questions about this talk, or if you have anything to further follow-up you need, you can reach out me through the LinkedIn. I leave the forum leave the table to gather open questions. If there is any, I'm happy to answer.
Hello, thank you so much for this insightful session. We have few questions from different platforms like Meetup, YouTube, and personal. So I have tried my best to arrange them like accordingly, but would recommend if you could answer these. Actually, these are 13. If you could answer all, it would be best. Or if you wish, you can just answer few.
Okay, I just reading through. Let me see. Okay, the first question is, as a student trying to break into data and AI beyond the hands-on labs, what is the absolute first tool or component within Microsoft Fabric as a beginner should focus on? I think there is no one tool which you can focus on to get an expert, right? Because the Microsoft Fabric is a suite of applications which bring in the core components that we discussed earlier: how to ingest the data, how to identify the pattern, how you can integrate these data into the model, and then how you are going to take an action. So when you think about it, these are the four major pillars: bringing in the right data, understand the pattern, ask the model to detect anomaly. When model is detect anomaly, how you are taking action. And I think most of the hands-on lab provides the end-to-end how you are going to do it. And then it depends on some of the data set. And then you need to bring in what problem you are going to solve. Um, since you are a student, you can think about take some hypothetical use case. As I said earlier, what if there is a customer, um, the customer service experience? What kind of a data set you can build in, and what are the things you want to do it in all those four pillars? I would strongly recommend learn from these four verticals, and then focus on tooling. Is anytime we can learn it, and tool also could change time over the time. But understanding how to scrub the data, how to understand the anomalies, and then how to visualize it, how to take action. Those are the core concepts which we need to understand. Okay, the next question is for professionals from a non-AA background. Which specific fabric skill is most valued by employers today? I think it's I some of the question I already answered in my previous question. There is no one specific fabric skill, and if you really want to achieve the benefit of Microsoft Fabric, that means, again, I'm repeat it, you need to see how to ingest the data. Ingesting data could be straightforward. All you have to do, find a way how to bring your data into one lake, and then having a direct link is, again, it is accessing the data. But think what you need to understand is what's the problem you are solving, and then what the ML model you're supposed to be employ. I think that's a very critical, and that comes in a practice, because we have a lot of options to choose different models, and we may need to try out. There are a lot of parameters tuning happens. I think that is the critical thing which comes in experience. And then the triggering part, again, it's as a trigger as a concept is not something new for even for non-AI background. That's been there for uh, plenty of other systems. It's basically the notification. You are listening to the notification, and then you take some certain action. And that action, what you are taking, is it going to directly touch some of the data, or what kind of decision it is making? I think that is, again, not a big deal. In my opinion, the hard part going to be is the tuning, and then training your model, tuning your model, and then you understand the characteristics, performance characteristics of the model, and how you are going to improve those characteristics. That's a very critical thing. And it has also has some kind of a science overlap. If you ask me what's the most valued by employers, I would say that yes, the tuning is the most valued, because that is where you get most of it basically. Okay, the third question is, how do you handle the initial challenge of transforming raw source data into well-structured delta tables, require direct lake, and the ML models? This is a problem I would say in past, but in some of our workloads, or we have uh, very unstructured data, and in those cases, what we did is we used the Copilot, and then we given some sample data, and then we asked the Copilot saying that, hey, this is a sample data I have, can you come up with the better schema for it? I think we should realize that some of these LLM based approaches could help. In this particular case, we are not employing them in the real world analysis scenario, but we are using those Copilot to understand the pattern and how to define a schema for your pattern. That will be one possible option if you can't derive the right schema for your models. um, at the same time, we can also see that if we can use the raw data directly into the model, some of the models can understand and then extract the data on the fly. We could try that also, but that will be a little bit expensive. But if you really want to define your schema for your data lake tables, I would start with the Copilot first, and then see if that gonna help us or not, because that will definitely help you. You can also give that. You can make it incremental. Take some sample, get the few first schema. When you prompt next time, use the same schema what you already identified. Ask for the improvement. It is gonna be multiple iteration, but you could get some help from the Copilot. Number four, when training models, what is the decision criteria for using Fabric Notebook versus Azure ML Compute Cluster? I think it depends on what model you are using. Um, um, Most of my experience, the workloads what we use is our ML compute cluster, because the nature of the data what we process, it again depends on the volume of the data and then how much you want to scale. I think that's where it is going to be. It's basically the infrastructure where you are going to execute. From the model, you can choose the model either from your Azure ML or from the model is the same, right? Basically, it's infrastructure where you want to execute, what's the volume of data you want to execute, and how faster you want to get the result. And that's where going to make the decision between where you are going to deploy. But my workload is always dedicated compute cluster for my models. Number five, in moving to data activator, how do you avoid replacing dashboard fatigue with alert rule fatigue when setting initial thresholds? Um, I think the activator is basically there is something you detected, you predicted, there is something bad going to happen or about to happen, and then you are alerting, right? So um, I don't know how it is going to replace the dashboard. Activator is basically taking action on the data. Maybe I'm a little bit having difficulty what you mean that it is going to change it, replacing the dashboard. At the same time, the threshold what we are setting on the rules, it's basically it's the we need to that's where we need to have a continuous fine tuning, human in the loop to understand what's really happening. And then we need to tune the rules based on the threshold what we set up. Apart from that, maybe I have some difficulties on what exactly the question asks here. Number six, how do you socialize AI-driven insight with engineering teams to build trust and ensure they act on the recommendations? I think I covered in the one of the slide the trust we need to gain from not only from the engineering teams and also from our stakeholders and our leadership, and then we need to prove them okay this is going to help them. And one of the way is take small example use case and then use the right model, use a safe um, the safe action, and not only that it finding an anomaly and then it is triggering that for that anomaly creating a ticket. Also make sure that how you can simplify reaching to the RCA. If you take one example and if you give that the demo or you do as the POC for one of the feature, and when you're able to do that, you can easily gain a trust from your engineering team because it reduces their time to reach what is the root cause analysis that it will reduce. It helps to maintain a system health. That's where the product management you can get the buy-in, and also it keeps the overall quality of our system and reducing the customer impact. That's where we can gain a trust from our leadership. I think we already covered some of the critical five things: how to make your data ingested data is correct, and then how we are continuously measuring, and then how we are going to um, um, validate the ROI, right? I think once we have this entire framework set up, we can easily win over our stakeholders. How does Fabric Purview integration work in practice for automatically scanning and classifying data for real-time like event streams? I I don't have the direct experience with the Purview integration, but we use event stream because most of our data, what we get is from the event stream, and then we try to scrub the data, summarize the data, and create that pattern. Maybe I know about Purview, but I never had any direct experience with that. For an early stage startup, is there a quick win use of AI augmentation in Fabric that delivers disproportionate value? Um, I think I touched base some of this in my talk. Don't think AI is your magic solution. You first define what you want to achieve. Write down your requirements very precisely and clearly what you want to achieve from it. Have these requirements. And if you are doing as a human, how you will do it. And then what are the challenges and pain points you face. And then how you are going to resolve those pain points using the AI. As I said earlier, don't throw the problem to the AI in the hope of it will going to solve it. If you don't know what you are solving, AI also doesn't know how to solve the problem. So be very precise. And you might read the recent article about how the AI companies are succeeded. And that article says that 95% of startups failing on the AI because they don't know what exactly they want to do. But the 5% of the companies who succeeded with the AI, they just use it for that one purpose which they want to solve it. From a startup point of view, the main thing you need to understand is very clearly understand what problem you are solving. Don't be abstract, very specific. And then for that specific requirement, think about what are the pain points you have and how those pain points going to solve by the AI. Without understanding this, whatever the model, whatever the cash we burn, it's not going to help. It's not going to solve our problem. Be very, very precise on it. What does the migration path look like for enterprise with the existing investment in other clouds or data tools? Um, I don't want to talk for just for the Microsoft Fabric, right? Microsoft Fabric. is one of the suite of applications which helps you to bring in all the data under single umbrella and then have the seamless integration. That doesn't mean that you need to go to your org and then ask your org move away from your current cloud and then go to the Microsoft Fabric. um, I don't want to talk for it, and I don't think so that's the right talk here, right? So understand, if your org is not in Azure and they are in different cloud platform, understand the concept of the underlying characteristics. That's a very key. In any software, we need to understand what is that underlying architecture or the core concept, and how to find those core concepts in other. I worked in different languages in my experience. I started with C++, then C Sharp, and then Java, now with Python. But it helps. Some of the learnings from one of the language may not be directly available in other language, but we understand the core engineering concept, what we use there, and then we try to mimic the same thing here, right? I think the main thing is, it's not, I'm not advertising that you have to use Microsoft Fabric, but what you need to understand is what are the core concepts. The core concept is how to do data ingestion, scrub the data, how to employ your data models to understand your patterns, and then how you are going to present the data to your customers. And then not only presenting in a visual representation, and also enable the natural language interaction with your data. And then finally, how you are going to make automated action. I hope all most of the cloud platform, all these things, but they don't put in everything together in single umbrella. I think that's one of the biggest advantage we see in Microsoft Fabric. But doesn't mean that you want to force your enterprise to move to the different cloud. I don't think so. I don't want to speak for it in one or another way. Okay. How can the AI capabilities in Fabric be leveraged to create entirely new customer experience or product offering? Um, so there are certain learnings we can take from our existing behaviors. For example, when we are going for a specific customer facing feature, we can go to the previous year. Maybe we already have different customer facing feature, how that interaction going to happen, and what kind of a demand, infrastructure demand we had earlier. And those kind of learning, we can definitely take it. But from apart from that, how the customer behavior going to be, we can predict it. We could use that same information if the characteristics are same, but we can't absolutely show that, hey, this is what going to happen, right? It's this is where pretty much in any of our planning, when we do it and we understand some of the pattern from the history, and then that is why based on that we will prepare ourselves to be to support when that need happens, right? So most of our AI capabilities, again, it goes back to the out of distribution, the discussion what we had earlier. In this particular case, you can assume that your AI can handle the out of distribution. In this case, it's an unknown scenario. And we need to understand that how well that unknown scenario your AI or your AI ops can predict. That's where we need to also understand it's not the biasing towards what it already knows, and we need to measure it. I don't think so. If the characteristic is completely different, the product offering is completely different. For example, you do your business X, now you're doing entirely business Y. I don't think so. We can take the business X characteristics and then apply into business Y. But there are few learnings you can have it. And the key to success of any of our AI capabilities is to understanding the pattern from the history, and then it can predict it. So apart from understanding few basic uh, the behavior from our current customers, I I don't think so we can get much benefit in this particular case. What does operational model for proactive intelligence team look like? Should experts be embedded or centralized? It depends whether you want to have embedded or centralized. It depends on how big your organization is, and then how many of these AI ops you have it, how many of them are required, the special tuning versus you could centralize for your entire org and then you can use our shared services. There is no one solution available. It changes organization to the organization. So if you see there is a benefit of one science resources and then they can tune all these parameters, that could be centralized. But if it is very the customer behavior centric, which is only can be tuned for your own services or your own future, then you need to go for an embedded. So I don't think so. There is a one right approach. It depends on how your org is set up. In pay-as-you-go model, what are the primary cost drivers and strategies for keeping them predictable? Again, you need to look back. This again goes back to your ROI discussion. So you need to understand that where you are spending. You can take your monthly bills and then understand that where is the cost you are spending it, and then find a way if you want to optimize it. And then instead of optimizing for your expenditure, think about what is the benefit you get out of it. You can burn a lot of cash, but if your return of investment is very low, then it's a questionable, right? I think this goes back to our ROI analysis. Again, the ROI analysis, it depends on what problem you are addressing and then what solution you are providing to your customer. And then you need to have that framework embedded. I think this is where going to your interaction, the human interactions, basically to understand what is the benefit you get out of it, what is the precision you are making it. If the model is making a lot of wrong choices and then every time human overrides and intervene happens, then it's questions that having that whole the automated workflow in your systems. So that's where you need to do ROI study. And then anything on a pay as go model, it always you go back and analyze that which component you are paying more and why you are paying more and how you can optimize. And then again, when you optimize it, how it is going to impact your decision making. It's like you need to get the balance, you need to get the trade-off. Again, it's a continuous exercise. It's not like you do once and then you stop there. You have to do this continuously, month over month. That's the only thing where you can keep your budget intact. Could you give me an example of specific metric or process within Fabric to proactively detect biased outcome in personalization model? I think the bias outcome again, it goes back to when most of the biases we use it when unseen data happens, how the model is reacting to the unseen data, and that's where we do. And then classifying what is known and unseen model itself a challenge for us, and that's where we always do a sample audit, and then we will see that okay, this is the data, this is the outcome happen, is this outcome really good or bad? And that is how we will do it. When we validate our system outcome, we don't validate the quality of the input, but we validate the quality of the outcome. And when the quality of outcome is unexpected, then we try to trace back why this has happened and is there any pattern is emerging. And some of these things we do AI auditing another AI. That is one approach we take. That also gives us the high volume. And after the AI audit another AI, and then we will take the audited result, and then we use some human to validate what is the precision of that AI auditor itself. There are different mechanisms which we could do it, and one of the way how we detect the biases, taking that outcome. than trying to classify what kind of input we are getting. And especially when you are dealing with billions of data, classifying input going through every billion of data is really hard. But if you can understand the outcome, the some outcome very simply, that how many times you override the data using human intervention, and then why you override the data, because the AI model made a wrong decision. Then you can take those samples and then go back and understand why AI made this decision over what the human override is providing, and what is the gap. You try to understand it, and that is one of the way we could do it. And it has to be, some of these things can't be proactive, because model tuning is always going to be a continuous exercise, and then based on, as you get more and more output samples over the period, you can tune the models, and then you can make it best outcome. Okay, the last question is the implementation tips and timelines, including change management around AI augmented product and system management. um, as I said earlier, the major tip is start small, be precise on what you want to achieve, write it down saying that, hey, this is what I want to do it. Be very clear on what you want to achieve it, and then go and research on how you can achieve it. There are multiple models available. What is your right model? Try out with the different experiments, get the result. When you start with the small, one of the advantages, you are not dealing with the large data set, which is going to be time consuming to understand what's really happening. When you start small, you can try with different options, different parameters, take the output, go to the human audit. Since you already know that what is happening, since you know that already what is happening in your system, and since you already defined that clearly what outcome you want to achieve, you can audit that small sample. And once you get the confidence, now increase and scale your small experiment to the wider scale gradually and but faster, and then get some samples, audit again, make sure continuously your model is doing the right job, that again whatever you define. I think that's the only way where you can be successful. Otherwise, please don't assume that AI is going to be a magic bullet. We need to be very precise on what we want to do it. Okay, that concludes all the questions what I had. Maybe some of the questions you may have some follow-up questions, or you may not get the right answer. But we can reach out to me in a LinkedIn or in any other way. I will try to provide more pinpointed answers if you want it. Okay,
Thank you so
that
much. It was really the insightful session. And thank you so much for clearing so many doubts. And yeah, people are not present here, but if they will have any question, I will recommend them to reach out to you via LinkedIn.
cool.
Okay, so before ending, I would just give the mic to you. If you want to share any one piece of advice for the community or the others watching this, apart from the domain specific questions, just for the life or something like, or just for students, it would be
Yeah,
best.
I think thanks for having me. And this is the my my first public speech after a very long time. When I used to be MVP, I do a lot of community talk earlier. But after out of MVP community, I never had an opportunity to speak with public forum. Thanks for having me, giving the opportunity. And for the community, I think we have to. The landscape is very fast. It's changing very fast, right? So when we when I started my career on ML like 10, 12 years back, when I get first hands on ML, we were struggling quite a lot on getting a high precision, high recall. We need to have plenty of label data and everything. When LLM came, that entire paradigm shift happened where we don't need any training data, and we are able to achieve the high precision even with zero shot, basically. So the paradigm is changing. At the same time, we need to understand that some of these the solutions are expensive. So we need to find and then up to date on what's happening, and then how to reduce the cost at the same time, not giving up or not impacting the precision or the accuracy what we are going to achieve. To be successful in our AI or ML implementation, this is a very key thing. We need to find a way, the trade-off, right trade-off between um, how to reduce the cost, at the same time how we can produce the best result. There is some sweet spot, but we need to identify what is the right sweet spot. I think that's the one thing I would recommend for this community, keeping in mind. And then there are a lot of things happening around space. Be up to date, and then find a way how to tune and cone your skill set. Um, this is not going anywhere. It looks like AI is changing a lot of things around the enterprise, how they traditionally operate. Um, so be up to date on what's happening. That's all I would say. Okay, that concludes my talk.
Once again, thank you so much for joining us.
Thank you. Thank you for having me. See you, folks. Bye.